Okay. So in the last lecture, we talked about the browser wars when Netscape and Internet Explorer were fighting for dominance in the late 1990s and early 2000s. But today, we're going to take a step back, a prequel, if you will, to take a look at what happened before those battles started. Because I described the early web in the last video as the wild, wild west, a place where users, developers, and IT staff were kind of making things up as they went along. And that's what the early web was like. There were standards written by Tim Berners-Lee, published on the first website at info.cern.ch, and shared on Usenet groups like www.talk, explaining about how the web was supposed to work so others could build compatible tools and publish their documents. But many saw these standards as kind of like suggestions.
It's like the same issue with
So it was like cherry picking what they liked while adding their own features wherever and whenever they wanted. So that's the downside of an open system. Browser makers started adding their own quirks and features without any coordination, creating a messy, fragmented environment that made it hard to know where your websites would work and if they would work anywhere. Now don't get me wrong, some good things came out of that grassroots, bottoms-up experimentation. For example, the image tag that we talked about before was not part of Tim Berners-Lee's original HTML spec. Mark Andreessen and Eric Bina, they didn't run the idea past Tim Berners-Lee when they created Mosaic. They just dreamed up the IMG tag and decided how it should work, and they coded it into their browser, Mosaic. And when other browser makers saw how useful it was, they copied that they stole that feature and put it in their own browsers too. They didn't need permission, and they didn't wait for some standards body to approve it. So while the chaos of the early web caused problems, it also allowed for a lot of quick innovation and practical improvements that moved the web forward. So Tim Berners-Lee moved to Massachusetts in the United States, to MIT, the Massachusetts Institute of Technology. He moved in 1994 because CERN really wasn't positioned to take the lead on the ongoing development and coordination that the web really needed as it started to grow so fast. So after all, CERN was a physics laboratory, not a center for internet research. So as it turned out, MIT's Laboratory for Computer Science, basically, well, they had the right environment. It was connected to the US tech industry and already was pretty active in networking research, and it had a strong focus on the internet. So with support from MIT and the European Commission and DARPA, which stands for the Defense Agency Research Projects Agency, and also a few industry partners, Timble founded the World Wide Web Consortium, or W3C, at MIT in October of 1994. And the purpose was to guide the web's evolution as an open global system. So this, that is the W3C, by the way, is what I was referring to in the other video as the sheriff in my previous lecture, as a governing body, in air quotes, which would maintain the standards. And by standards, I mean, suggestions for developers who are writing and publishing their own web servers and web browsers and websites. So forgive me as I continue my wild, wild west analogy, but as the web grew, companies like Netscape and Microsoft, they started adding, their proprietary features to their browsers to gain an edge in the market. So the big guns were like the outlaws of the early web, although it's hard to say which of them, if any of them, had a white hat or a black hat. In any case, having them wield their influence over the fledgling web created chaos for us developers. So websites might work in one browser but break in another, and new features often only worked in one place with no consistency across the web. And this fragmentation risked turning the web into kind of a patchwork of closed, incompatible systems, which was the exact opposite of what Tim Berners-Lee had envisioned with an open, universal system. So the new W3C was given the charge to keep the web open, interoperable, and based on shared standards rather than corporate silos. In its earliest days, the W3C focused on stabilizing HTML and developing consistent standards for styling and layout, which is different than its original charge on being focused on documents and structure. So this is where CSS, or cascading style sheets, enters the picture. Because before CSS, developers had to rely on HTML hacks and proprietary tags just to control things like fonts and colors and layout. And these tricks only worked in certain browsers. For example, Netscape introduced tags like the font tag to change the typeface and colors, and blink to make text flash, while Internet Explorer had its own marquee tag for scrolling text across the screen. And these features were never part of any official HTML standard, and they worked inconsistently across browsers, making consistent web page design a constant challenge for developers. And so it also meant structure and presentation. The HTML versus the CSS layer, as we have now, they were mixed together into the HTML, making code messy and harder to maintain. So that's why in 1996, while the browser wars were just getting warmed up, alongside maintaining the HTML standards, the W3C established the CSS Working Group, and they released CSS1, or version 1, which created a separate standardized way to handle the look of web pages while keeping the HTML focused on structure. By the way, it's helpful to understand that the W3C isn't a company. It's a membership-based organization that includes technology companies like Apple, Microsoft, Google, and IBM, along with universities, research labs, and nonprofits. So members, they pay an annual set of fees and dues, and they send representatives to working groups that are managed by the W3C, where standards are developed, and through drafting and testing and consensus, they basically define the standards for the web. And Tim Berners-Lee, well, he served as the W3C's director, keeping the mission focused on openness, accessibility, and interoperability. And by the way, it's worth noting that there's a bit of irony here, because both Microsoft and Netscape were members of the W3C from the very beginning, participating in working groups and supporting the mission of an open, standards-based web, while simultaneously launching their own browsers, which was packed with quirky proprietary features that often broke consistency across the web. So keep that in mind, that while companies could agree on the idea of standards, competing market share often led them to stray from those principles in practice. Within just a few years, the W3C helped stabilize web development, because they started by publishing HTML version 3.2 in 1997 and HTML version 4.0 later that same year, formalizing structure while adding capabilities and maintaining backwards compatibility, and CSS1 in 1996, which brought consistent way to manage what we call the presentation layer across browsers. The W3C didn't solve everything overnight, and as we talked about before, the browser wars continued for a while, but the creation of the W3C was kind of like at a turning point, shifting the web from chaos toward a shared set of guidelines and collaboration, allowing it to grow while still remaining open. And remember what I said back in the intro, knowing where the web came from helps you understand why it works the way it does today. The standards that we rely on now, like HTML and CSS and others, they were shaped by that messy, collaborative, sometimes chaotic history that we've been talking about all this time. So when you run into something weird or outdated in web development, it's often a relic of these early battles for consistency and openness. Standards exist to keep the web stable and interoperable, ensuring that whatever we build will work for everyone, everywhere, across every web browser.